Happy Friday, everyone. Meteorologist John Homenuk with Empire Weather. Wanted to let you know I am traveling today, so the audio quality might be a little less than usual. I'm not using the Blue Yeti mic that I usually have and typical audio setup, so might hear a little bit of feedback. If you guys have any problems understanding anything, just let me know, and I'd be happy to let you know what I was talking about. But should be okay. These MacBook Pros are pretty good with their microphones these days. So I want to start off by looking at where we've been for the last 60 days. I think, there's been a lot of noise and a lot of back and forth and weather model data flying all over the place. And I thought it would be prudent to just take a step back and look at really where we've been. We've been back and forth with ridges and storm clusters and here and there. But what does it look like if we take a step back all the way to where we started? So this is the 60-day, taking us all the way back to the end of May. These are the areas that have gotten hit and the areas that haven't. And so the first thing that really sticks out, obviously, to me, is the area over the southern plains. This area has consistently been very dry. They've been way below normal in terms of precipitation. And the drought has really expanded throughout this entire area. Parts of the southwest and western Texas have been extremely dry. Even parts of eastern Texas into Oklahoma, and more recently into parts of Missouri and northern Arkansas, as well as western Kentucky and Tennessee. Very dry in these areas. There's also been an area of dryness from eastern Nebraska into Iowa. This area has missed a lot on thunderstorm chances, as well as central Minnesota into far west central Wisconsin, and this small area in central eastern Illinois and west central Indiana. So these are the problem areas that we see right off the bat that stick out to us, right? These are drier than normal over the last 60 days, which is a really long period of time. The 4-week change on our drought monitor tells us that a lot of this has happened in the last 4 weeks. Because if you look at this is a 3 to 4 class degradation of conditions in this region. Now we know drought is a long-term pattern indicator. It's not necessarily a short-term indicator where we can say, oh, here's what happened recently, and this is why the drought monitor looks like this. This is a long-term indicator, but to see this level of change over a 4-week period is extremely impressive and indicative of just how dry it has been in this region. We also see drought expanding here in parts of Iowa, and we see a 1 to 2 class degradation here in parts of Minnesota as well. And this drought has spread into parts of western Kentucky and Tennessee. Our clients there you don't need me to tell you, it's been very dry. And this is obviously very impressive. And when we look at the root zone soil moisture, so the moisture content in the top 1 meter of our soil, we can see exactly the same. We have these dry conditions spreading up from the southern plains into the central plains, and you can really see exactly how this is maneuvering. And when you go back and match this up to what we've seen in terms of precipitation departure from normal over the last 60 days, this is what makes a lot of sense to us. Now, in the short-term forecast is opportunity for many. And I want you guys to keep your eyes on this region in particular. This region is going to become very important later, but this region first. And look at the forecast on the Euro ensemble for the next 7 days. I'm going to flip back and forth here. This area right here is forecast to have some extremely beneficial rain, even with the possibility of flooding. If we zoom in and look at the forecast from the European model here across this area, parts of western Kansas could see up to 3 inches of rainfall. It likely won't be this widespread, but we could see 1 to 3 inches of rain in this general region through the weekend. This band continues all the way eastward through parts of southern Missouri and northern Arkansas, western Tennessee, Kentucky, southern Illinois, and Indiana. And if we go back to this, with the 60-day departures, it's right in this region that really, really needs it. You almost couldn't place it any more perfectly than the model currently places it. So this is very important rain that we need to verify across this entire region. But I want to go back again. We just talked about parts of Iowa and parts of south central Minnesota that have been too dry. And you can see that visually right here over the last 60 days. There's not much relief coming over the next week here on the European model. All of it is in the south central regions here. That's where a lot of this relief will be, which we'll take, but this is an area that we're going to need to focus on. Let's look at what happens and how it all goes down here. So This is our frontal boundary over the next couple days here that we want to keep our eye on, right? We have one disturbance that's coming off of it today into tonight, sliding eastward. We have a second one that develops on Friday morning across eastern Colorado, parts of western Kansas, down into Arkansas and into Tennessee and Kentucky. That moves eastward. Look at this rain just kind of sitting and hanging out in parts of western Kansas all the way through Friday. The front lights up again late Friday into Saturday. And additional disturbances reform on this front again Saturday morning. So it's really just the same areas getting hit here over and over. Now this takes us into Sunday afternoon. The front has finally moved east of Kansas, but it's still impacting these areas here through Sunday. This whole time, there's almost nothing going on across Iowa, southern Minnesota, northeast Missouri. This whole corridor is quiet. The front is down here. And we'll watch those disturbances come through. Today's European model and yesterday's had this sort of storm complex developing here in northern Minnesota and sliding southward. This could provide some precipitation to parts of Minnesota and maybe northeastern Iowa Monday, but we're not really counting on that to be a big disturbance. Instead, we expect it to sort of grab the front that's been sitting here and tug it off to the east, and you can see that happen here. So by the time we get into early next week, we have high pressure building in across the plains. And that's going to be the time frame that we're going to start to see this warmth collapse and begin to move eastward. So let's take a step back. That takes us through the weekend and into early next week. So what's happening now? We've beaten this point to death, but what's happening is we're reverting back to a pattern that we saw earlier in the spring and very early summer, where you have ridging north of Hawaii, and that helps to develop troughing off the west coast and allow for ridging to expand further into the central United States. Earlier in late July late June and early July, this warm water was back here further to the northwest, and that kept the pattern looking more like this, which allowed these disturbances to come down and kept the ridging more centered in the four corners. Temporarily, this warm blob here is gonna help us. It's also a sort of a process, a result of the process. But regardless, we're going to have ridging building back into the central United States. El Nino is still cranking. The machine is still running here. But when we look at the ensemble evolution and we watch how this plays out and we look at what happens early next week, it's no surprise that the models are warming things up because our ridge is no longer in the four corners, at least initially. It's way out to the east here across the Central Plains and across parts of the Ohio Valley. So if we back up and look at North America and we look at what happens to cause this, you can see that our active pattern, which we are currently in, right? We talked about the ridging being here and the troughs coming down here. That pattern vacates because the ridging retrogrades. And a retrograde is when the ridging is centered in one location, and instead of moving eastward here, which most things do in the mid-latitudes, it will recenter itself back here. Watch this ridge recenter itself here over the next week. Here's the ridging, and there it goes. It's back in the Aleutian Islands. So what that will do is it will encourage troughing to develop down here. Your wave pattern is going to start to look something like this, at least temporarily, right? So here it comes. Your troughing comes into the Pacific Northwest, and you build a ridge into the Ohio Valley and into the central United States. That is likely going to lead to a period of warmth. If we zoom in and we look at the temperature projections here across the central United States into the early and middle part of next week, it is very warm across the Midwest and obviously the southern plains, which just continue to be warm. But it's also built now into parts of the Midwest and spreading into the Northeast as well. That's not a surprise based on the pattern that we have. If we back up and we look at what this pattern looks like across North America, we have a Western Atlantic ridge. We know that air flows clockwise around ridges, right? So we have a Western Atlantic ridge that's bringing warm and moist air in here. And we have this ridge centered here, which is bringing all of this hot air in over the top from the drought regions. And so this is just a very hot pattern, really from the upper Midwest into the Northeast states. It's very classic, really. And so when we look at what that means from a temperature perspective, you can see that the models are very warm, several degrees above average, specifically from the middle to latter part of next week. Now, I wanted to take one moment here. We know it's going to be very hot, and it's going to be dry because the moisture sources are cut off during this situation. But I wanted to talk about the GFS for a second. These high temperatures are not going to happen. The GFS is having a land surface feedback issue and it's having runaway feedback issue where it's having trouble handling what's going on at the surface, and it's just unable to stop itself from running away with this extreme warmth and moisture. So this feedback issue is causing temperatures to be way too warm. Now, it doesn't mean they're not going to be warm, but if we compare the GFS and the Euro, which this is valid Wednesday afternoon, next Wednesday afternoon, the GFS is forecasting all-time record highs in parts of Iowa. That's not going to happen. Let's flip over to the European, valid for the same time. This is more like it. We're talking mid to upper 90s across this region, which is still very warm. I don't want to discount that at all. But it's not quite the warmth that we are seeing on the GFS, which is wildly incorrect and way too warm. And I want to just make sure that that is known, that is a feedback issue in the operational model and in the ensemble. So you're looking at a model that is way, way, way too warm. These temperatures are not going to happen, and that needs to be factored into our process here as we move forward. So we have the warmth settling in, and it really sticks around here through probably the first week of August. But I want to go back and look at what's going on aloft again. And you'll notice we talked about what happens here initially is we get this ridge that builds in the Aleutians, and that forces troughing here and allows ridging to expand in the central United States, which is different than what we've seen, right? We haven't seen ridging in this general region, and we're seeing that now because of this general configuration. But what the models are doing is retrograding. We talked about that, right? The ridge was here, now it's here. And there's very good indications, without much help from the MJO or tropical forcing to move the Pacific jet along, that this ridge is going to continue to retrograde. So if you watch the European ensemble, that ridge eventually, it ends up back here. It's almost off the screen. And so that's going to allow all of this vorticity and momentum to come down further west. And it's going to give this ridge room to do the same thing it's done all year, and that's end up back further west. Watch the European model progress this ridge back to the west here. You can see that happening so clearly at the end of the model run. It's almost back to the four corners. Now, granted, it's still an expansive area of ridging, but it's centered further west now. It's not over here like it was during the first couple days of August. And that's important because if we zoom into the United States look, you can see that a lot of the agriculture belt is on the periphery now of this ridge. And if we track down the model's anticipation for how the moisture will evolve, you can see exactly why that's important. The ridge moving from this region back to this region is bad news for areas like Texas and Kansas and Oklahoma, because it means that what's going to happen is the moisture that's sitting here in this monsoon reservoir is going to come over the top of this ridge and likely end up with storm clusters coming back down into the Ohio Valley here, from the upper Midwest into the Ohio Valley. As usual, Iowa, Missouri, they're going to be on the edge here. This has been a problem all year long, but the chances for storms should come back as this ridge retrogrades to the west, and the major heat, which we see early on, should begin to slowly move back to the west. It's not going to go away completely. This is still a pretty warm pattern overall. But the big major warmth, which starts when you have a ridge in this region and your air is advecting directly in from the desert, is going to change. Because if you back this up here all the way to the west, which is highly supported by weather models, your flow now into areas like by areas like Minnesota, Iowa, Wisconsin, your flow now is this way. Let's compare that one more time for a visual and why we're confident in this. When your ridge initially builds here during the first couple of days of August, this is your flow, right? Coming right out of these drought regions around and over the top. That is a very hot and likely drier than normal pattern for the entire belt. When you back the ridge up and allow it to retrograde, your flow changes. And now you have a flow that is coming over the top here. And when your moisture in this general region is coming up, intersecting with these Canadian disturbances, you're likely going to influence and open up the door for storm cluster chances as we move closer to the middle of the month. So that is the general overview of the pattern. You're likely going to see models go back and forth a bit here over the next couple of days. And I don't want to undersell the warmth that we're going to go through here in the first week of August. It's definitely going to be substantial. Be careful with the GFS high temperatures. The 115-degree stuff isn't going to happen, but it's still going to be quite warm and it's going to be dry until we get this ridge to move back to the west. The timing of that retrograde Still uncertain and is going to have to be determined over the next couple of days. But as we approach mid-month, we should get ourselves into a better situation here to get moisture back into these key areas moving forward. We'll have a lot more for you as we go through the next couple of days. As always, if you have questions, please just reach out to us. We are here and happy to help. For now, have a wonderful Friday morning. We'll talk to you guys very soon.